This is lecture 4, the second video in lecture 4, and we're continuing kind of our program flow control introduction, and let's do it. So what we're looking at is just instructions in general, and so there's only two things that instructions do. They either do something or they go somewhere else and do something. So what we're interested in today is going somewhere else to do something. So that means in programming language, that means a jump or a branch. And I know you've seen those in a normal higher level language, but we need to look at it kind of in more in depth here. Okay, so what we're looking at is a couple things, is what instructions do it and how it's done in hardware. So it's super important. We need to be able to do it in software, and we need to be able to do it in hardware. Okay, so once again, the two main reasons why code jumps somewhere else as opposed to executing the next instruction in memory, and one is like an if then else statement or some type of loop construct, and also, you know, a topic for another day is subroutines. Subroutines is going to say, hey, go somewhere else and do something. So for the programmer, once again, these instructions say go somewhere else and do something. So there's two types of go somewhere else and do something. Go somewhere else conditionally and go somewhere else unconditionally. So when I go somewhere else unconditionally, that means, typically speaking, we call it a jump. If I go somewhere conditionally, that means it's a branch. So conditional branch, we'll say, means I go somewhere based on a condition. If that condition is true, I go somewhere. If that condition is not true, I just go to the next instruction. Okay, so for the hardware person, essentially that means that we're just going on to the next instruction. Otherwise, we're loading a new value into the underlying counter, and you'll see that coming up next. So the object that keeps track of where your program is doing is a program counter. Everyone knows it as a program counter or PC. It's typically a counter, which means it's counters are typically loadable since it is a register, or it's a counter, which means it can increment. Okay, so the increment is normal operation. It goes to the next instruction, whereas I'm loading something that's going to be associated with a branch or a jump. But this is an important thing. In the RISC-V microcontroller, we're always loading. Essentially, we're either loading some new address where we're jumping to, or we're loading the current address. This is the current address plus 4. So what it turns out here is the instruction memory, or all the memory, is byte addressable, but the instructions are 4 bytes long. So to go to the next instruction, we add 4 to it. Okay, so essentially what we're doing is, it will actually have an adder in the circuit. You add 4 to it, you load that new value into the program counter. So typically speaking, it's not going to be really a counter, though we're going to keep referring to it as a counter. It's going to be actually just a register. So the program counter is a register. Okay, so programming level, it's really straightforward to do jumps and branches. So typically speaking, the assembler does most of the work for you. And the hardware, it supports all the instruction formats, as you'll see later. So not a big deal on the programming level. The computer, on the hardware level, you need to understand the details. Not a big deal. There's a lot of simple things going on. It is simply just a register loading values, and we'll see that coming up next. This is the RISC-V architecture. Here's your program counter. Here's your memory. You can see that, like experiment 1, the output of this counter or this register is connected to an address input on the memory, which is accessing program memory. So this is the program counter. It's a register. You can see that it's loading pretend like it's a register. It's loading one of 4 values into this register. So it's either loading the current PC plus 4, which is this input right here, or it's loading one of these inputs right here. And if you look at these things, this, you can see this one's associated with a branch. I hope you can see that on YouTube. I'll write it here just in case. These two are associated with jumps. There's 2 types of jumps that we'll get into, but that's it. So it's always loading a new value. This one value here is associated with kind of an increment, go to the next instruction. These other 3 values are associated with go to somewhere else in the program. It's just a simple mux feeding a data input on a register. That's it. Shouldn't be a big giant new thing for anyone. There's always an issue of how to teach assembly language because it's hard to teach knowing nothing. So you have to start somewhere. And so I made the decision to plop these 2 instructions out there and show you these instructions first, because we're going to use them quite a bit. These are actually instructions that you use all the time, and we'll just go over them. So these are actually they're not base instructions, they're pseudo instructions, but they're very simple, and like I said, they're very useful. So this one is LI, which stands for load immediate. So what it means is it's going to load just a numerical value into a register. And this is what the instruction, this is an example of instruction. So what this says is take the value of 34, put it in register X10. So the value could be anything. I could use any register I want, technically speaking, except X0. I can't write to X0 because it's always 0. Okay, so that's one way of moving data around. The other way is to move data from, this is a move pseudo instruction, MV, and here's your example here. It takes the data in X20 and copies it into X19. So it necessarily overwrites what's in X19. This register here, or this LI instruction, overwrites what's in X10. So both of these are going to change specific register values. So this is, like I said, these are very, very useful instructions. Okay, so this is our first program. We're going to chunk through it. You don't need to understand it super in depth, but I want you to get a feel for it. Okay, so comments, yep. Comments, everything's lined up. It looks beautiful. All the instruction mnemonics are lined up. All the first operands are lined up. So first thing you see is these 2 load immediate instructions. It's taking these values here and putting them in these registers. So what this program does, and you'll see later, is this is actually inputting data from the outside world. This is a load value. It says load value from the outside world. Don't worry about exactly what this is doing. We'll get into more details later. Load value from the outside world, exclusive OR. Okay, I load it from the outside world, put it in X15. This is an exclusive OR immediate instruction where I am taking what's in X15, exclusive ORing it with a -1. -1 is, if you remember correctly, is all 1s and 2's complement. So essentially what this instruction is doing is taking what's in X15, exclusive ORing it with all 1s, which is, hopefully you remember, that is a toggle. So what this instruction is doing is toggling all the bits in X15 and storing them back into X15. At that point, I write the data out to memory, write the data in X15 out to the outside world. Don't need to worry about that. But most importantly, at the end here, I have a jump. This J stands for jump. It jumps to this main label. So what that means is it jumps to the instruction associated with the main label, which is this instruction right here. And we'll call it done. Well, we'll say a couple more things about this. So these labels are simply numbers that the assembler assigns. So essentially when it's jumping to main, it's actually jumping 2 instructions backwards. So what it encodes inside the instruction word is the fact that it's jumping 2 instructions backward. It doesn't really encode these values right here. It has a trick way of encoding it, and we'll get into that in a minute. So this is another instruction. This one, essentially, it has the same load, immediate values, but it has, what we have here is a conditional. So the last one we had jumps, which were unconditional. This is a conditional branch. What it says is this is a branch if equals. If the value in x10 equals the value in x11, it jumps to the instruction associated with that label. So it jumps down to this instruction. Okay, so once at that instruction, this instruction says jump back to main, it jumps back to this instruction. So what we have here is it executes this, this, this. It might jump, it might not jump. If it doesn't jump, it goes right to the next instruction, hits this instruction, and it jumps back to this instruction. Otherwise, if it does take this branch, it jumps down to this instruction, and it jumps back to this instruction. So the point being is that I am doing two things in this program. I'm jumping, which is an unconditional branch. I'm branching, which is a conditional jump. And I'm just executing the next instruction for some of these instructions. So summary here, I've got a couple different instructions here to do branches, and the real instructions are JAL and JALR. And I've never used those. I haven't had a need to. I actually used this one exclusively. You're going to need to kind of sort of understand what these are doing, but technically speaking, this is the one you're going to use in your program. So I've never even used the jump JR either. You don't really need to know that. What's important is this jump. We'll get back to that later. So these conditional branches, if the condition is met, it takes the jump. Otherwise, it goes on to the next instruction if the condition is not met. So the next instruction is simply the current instruction plus 4. And I'm going to say there's a whole bunch. I think there's like 6 pseudo instructions associated branch, and then there's seriously about 10 more. I'm sorry, there's 6 base instructions. There's about 10 more pseudo instructions, and I'm going to show that to you right here. We're running out of time on this thing. So these are all the branch instructions. There's like a ton of them here. These are simply the jump instructions. Okay, we'll get into more of that later, and I'm going to cut this off before it kills me.